Hi, the name of our project is House Price Prediction, and I'm the team leader, Rui Fang. This project aims to collect real estate data from the internet, predict future house price trends, and build a website to display all property information and prices, and visualize property locations and price on a map. We'll also provide insights into future house price trends. Next, we will introduce our program in parts.
My work focuses on web crawling, aiming to provide essential information resources for our data models. Below is the execution timeline of my web crawling project, which encompasses 5 major phases: requirement analysis, identifying suitable websites, selecting appropriate crawling techniques, coding, and finally testing and validation. In this section, you can see the source of my data. On this page, I have crawled 4 types of content: internal links, titles, image links, and HTML files. This image displays the data samples collected during this phase. Furthermore, this page demonstrates another data source, comprising internal links of real estate listings. From these links, I extracted basic information about the properties. This image presents the data samples for this phase. Inevitably, throughout the crawling process, I encountered numerous challenges. Here, I will elaborate on the 2 most formidable issues. Firstly, frequent visits to certain websites triggered anti-crawling mechanisms. To address this issue, I adopted 3 primary measures. One was establishing a proxy pool. The second was rating a proxy server, randomly selecting a proxy from it as the request header for each visit. And the third was setting appropriate intervals between visits. The second problem pertained to the strong security awareness of website developers. The specific historical price information was hidden, preventing me from extracting it directly from the current web page source code. I speculated that there might be a data interface, so I meticulously examined the network activity on the web page one by one. Although this process was extremely time-consuming, I eventually located the HTML response of the interface, analyzed its path, and successfully crawled the data. And this page, along with the next, showcases the data samples, revealing the data acquired. With that, the web crawling project was successfully concluded.
The next section explains the data analysis and modeling portion of the section. The whole process is roughly divided into 4 steps. First, data analysis is performed to observe anomalous data and the characteristics of the data. The data is then processed based on the observations, performing operations such as removing anomalous data, removing low correlation features, etc. Next is the most critical step, model selection, testing different scalar, models, and parameters. Finally, the data is visualized so that it can be displayed in a web page. I used a variety of tables and diagrams to analyze the data. For example, the first heat map in the figure shows the high and low prices at different latitudes and longitudes. The second diagram shows the correlation between different features. Modify the data based on the results of the analysis. For example, remove all data with a price of 0, convert dry strings to longitude and longitude, using Google API to make it possible to train with the model. And then model selection. Split the data into 3 groups, 2 groups using standard scalar and min-max scalar respectively, and 1 group without scalar. Next, I'm using grid research to test the effect of different parameters on the model. I chose to use the MAE, MICE, and R-square metrics to review the model. They can evaluate the model from different perspectives. 3 algorithms were finally chosen as shown in the figure: random forest, gradient boost regression, and XGBoost, all using standard scalar. Eventually, I plotted the predicted data as a line graph and embedded the data analysis into a map, where the size of the circle indicates the area and the color indicates the price.
Through the Google Maps API, we display the data on the map. In order to let users know the approximate price of a region, we add a heat map on the map. The redder the color of the heat map, the higher the price, which can let users quickly understand the situation of the price of this region. The visibility of the marker is determined by the scale of the map. If users want to see more detailed data, they can zoom in to see the markers representing the house. Markers will not appear on the map initially, because displaying too many markers at once will slow down the browser and cause lag. Users can also search for the address they want to query by using the search box. The search operation resets the zoom level of the map and displays the addresses that match the search result at once. When user click on the marker, an information box will pop up showing the property details. This information includes the price, the address, the number of bedrooms, the number of bathrooms, and the square footage of the property. In addition, we also provide a variety of controls to help users learn more information. Users can view the terrain and switch between maps and satellite maps. If user drags the pigment on the map, they can see the actual street view.
Let me introduce our website and design concept. I have learned and utilized the React to develop our web page. I aim to create a simple yet highly interactive website. Therefore, I have chosen a high-end overall style using a light black background and concept text to present our web page. I have also incorporated various animation effects. The main problems encountered during development are the first implement complex animations such as water waves, and photo display. The second, successfully integrate maps and algorithms. The third, implement search and filtering functions. After entering the homepage, our main functions are displayed in the navigation bar. When users hover their mouse over the navigation items, detailed explanations pop up to assist users in navigating our website effectively. Clicking on Display redirects users to the Image Showcase section, where several popular or potentially interesting houses are displayed. I have implemented a smooth image switching effect for this section. At the bottom of the page, a wave effect have been added to enhance the sophisticated feel of the website. Now let's return to the navigation bar. Clicking Search here takes users to the display interface showing all available houses. And user can also enter keywords in the search box on the home page to filter and display houses based on relevant criteria. Clicking Map or this photo will direct the user to our map page. I have maintained a simple and intuitive layout for our page. Our functions buttons are displayed on the left side. Hovering over these buttons provides user with the specific function explanations. User can also input keywords to filter and search for houses. When users select a specific marker, their three buttons generate data analysis graphs based on three different algorithms. One button shows all his markers on the map, while the other two buttons display heat maps based on different variables.
The fifth part is about server setup. Now let's look at some server details. which was Amazon Web Services, for the AMI and server configuration I have listed, and given that we are in Auckland, so we chose the nearest server to us in Sydney. For building the database on the server, we used MySQL language and used Navicat Premium to process the data. For building the web pages on the server, we used NGX to deploy the React project. Here we also write our domain name by entering it in the browser. You can see our project. In order to facilitate the maintenance and management of the server, we use the BT panel, which is a simple and easy to use Linux or Windows server operation and management panel. We did some basic configuration queries and performance tests on the server. The picture shows the specific results about some I/O speed, upload speed, and download speed. At the end, we did some performance tests and unit tests on the web page. This is about metrics. Some performance tests such as response time. This is a waterfall chart, which displays the loading behavior of our site in the select browsers. This is the rest some unit test about some buttons, input fields, images, links, and API.
Finally, let's summarize. Our project allows us to predict future home price trends and gain insight into the market outlook. And it has a user-friendly interface design, beautiful and elegant. This Gantt chart shows the division of work for the project. And here's our GitHub commit log. Through this project, we have learned a great deal about web crawling, data analysis, and website development. From requirement analysis to the final website presentation, the entire process involved multiple stages and technologies. Deepening our understanding of the future of data science and front-end development, we tackled numerous technical challenges, such as anti-crawling mechanisms and data interface extraction, which improved our problem-solving skills. In the end, successfully completing the house price prediction project and achieving data visualization provided valuable insights into future property trends. Thank you for listening.